Okay, picture this. It's 1985. You've heard all the buzz about the Apple Macintosh. You know, the mouse, the windows, icons. It looks like the future.
Yeah, absolutely revolutionary stuff.
Yeah.
But it's also this kind of closed garden, isn't it? Proprietary hardware, expensive.
Exactly. And meanwhile, most people, most businesses, they're still looking at these stark monochrome screens, right? Typing in these bizarre commands.
Is hoping they don't get that dreaded error message.
It was. Yeah, a pretty unforgiving computing world for most folks.
But what if? What if you could get that slick graphical feel, the mouse pointer, dragging files around, all that intuitive stuff, but on the computer you already had, like your IBM PC clone or maybe something even less common.
Now, that was the dream, wasn't it? And that was precisely the incredibly bold promise behind this piece of software. Software that looks so much like the Mac.
So much so that reviewers apparently got this overwhelming sense of déjà vu.
You got it. We're talking about Digital Research's Graphics Environment Manager, GEM. Right, GEM. Welcome to the deep dive. So, this week, we're actually going right back to the source. We've got the February 1985 issue of Personal Computer World.
Ah, classic.
Yeah, and specifically Peter Bright's Screentist of GM. He was looking at it in its pre-production state, so it wasn't even the final version.
Okay, interesting. So what's our mission here? What are we trying to figure out by digging into this old review?
Well, I think we really want to unpack this core battle that was happening in the mid-'80s, this fight between the Apple way, the closed, perfectly optimized system, the Mac.
Right, the beautiful walled garden.
And the other, approach the open, maybe slightly messier, but portable system, which is what GM was trying to be.
So how did Digital Research, or DR, try to fix those big problems everyone was facing? Making computers easier to use and making software run on different machines.
Especially when their solution looked suspiciously familiar, almost too familiar to Apple's thing.
And the irony here, the thing that makes this story just fascinating, is who is doing this? Digital Research.
Yeah. I mean, if you were around back then, Digital Research meant one thing. The command line, cryptic stuff. They were literally famous as the company which gave us BDOS error on A.
Oh, man. BDOS error on A. That phrase still sends a shiver down my spine, if you saw that.
Your afternoon was probably ruined, right? Trying to figure out what went wrong.
Absolutely. You had to understand things way down at the hardware level. BDOS itself, basic disk operating system, it meant a really low-level problem with reading the disk.
Super abstract, totally unhelpful for the average person. DR built things like CPM. Powerful, sure, but friendly, not a chance.
They were the masters of complexity, you could say. Deep system level stuff.
So for that company, the one the reviewer explicitly says was not synonymous with user friendliness.
Right.
For them to suddenly turn around and release this super friendly package that looks and feels like a Mac or a Lisa.
It's a huge pivot.
Yeah.
A massive gamble. It's like they were turning their back on their entire history.
They were basically betting the farm on this idea that they could tame DOS, make it graphical, make it friendly. It's kind of nuts when you think about their background.
It really is. So to understand why they took such a huge risk, why GEM even needed to exist, we need to step back and look at the mess that was the PC industry back then.
Right. The why behind it all. It really boils down to one word, doesn't it? Portability. Or rather, the lack of it.
Exactly. Let's talk about how fragmented things were. Before the whole 16-bit thing really took off, say 18 months before this 85 review.
The good old days of 8-bit computing.
Yeah. CPM was king. It was the standard. If you were a programmer, life was relatively simple. You wrote your code using standard CPM system calls.
And boom, your program, once compiled, could run on dozens of different machines from different manufacturers, Kaypros, Osbornes, you name it.
That's why software like WordStar or DBase became such giants, right? It's had this massive potential audience because their software just worked everywhere thanks to CPM.
But then came the 16-bit IBM PC, Intel 888 processor, and crucially, higher resolution screens.
And that just shattered everything. MS-DOS, the operating system on the PC, was, well, let's be kind and say it was basic, especially when it came to graphics.
Basic is putting it mildly. If you wanted your program to do anything visually interesting, like draw a detailed graph or manage multiple windows,
You pretty much had to ignore DOS. You had to write code that talked directly to the video card's hardware addresses. Poke values straight into memory.
and the second you do that, the second you tie your software to the specific hardware of an IBM PC.
Poof. Universal compatibility goes out the window.
Right. Because maybe Compact's machine handled video memory slightly differently, or Tandy's clone had a different clock speed. Your carefully crafted, hardware-specific code just wouldn't work.
It created this fractured nightmare. Developers were tearing their hair out, trying to maintain like 5 or 6 different versions of the same application just to run on the most popular PC compatibles. It just wasn't sustainable.
And digital research saw this chaos, this fragmentation, as the big opportunity, didn't they? Or maybe the big crisis they could solve for everyone not named Apple.
Exactly. Their first stab at fixing the graphics part of the problem was a thing called GSX, Graphics System Extension.
Okay, GSX. What was that exactly? Was it like a whole new OS?
No, not an OS replacement. Think of it more like a specialized toolkit, or maybe a universal translator just for graphics. It was a set of routines that you added on top of the existing OS, like DOS or CPM86.
So instead of writing code for, say, the IBM color graphics adapter specifically.
Right. You'd write your program using standardized GSX commands, like GSX draw a line from here to here, or GSX fill this shape with blue.
And then GSX itself would handle the dirty work, translating that standard command to whatever specific instructions the actual hardware on that particular machine needed.
Precisely. It acted as an abstraction layer for graphics, and developers loved it.
I bet they did. Write once, run anywhere, that's the holy grail.
You got it. And the source material mentions that GSX had already been picked up by about 75 different hardware manufacturers, 75 OEMs. That shows it was already becoming a kind of de facto standard for portable graphics before GM even arrived.
Okay, so GSX handles the graphics portability. How does GM build on that?
Well, GS basically takes that core GSX idea abstraction, keeping the application away from the specific hardware, and blows it up to cover the entire user interface. Windows, menus, mouse, icons, the whole shebang.
So it's GSX philosophy applied much more broadly. The reviewer actually calls it very much an extension of DR's attempt to keep applications programs as distant as possible from the hardware.
That's the heart of it. It's all about creating this consistent environment, regardless of the machine underneath.
And architecturally, how did they pull that off? You said it wasn't just one program.
Right. It's a layered system, a stack. You need several pieces working together. First, you need your base operating system, could be MS-DOS, could be DR's own concurrent CPM.
Okay, the foundation.
Then on top of that, you need a version of GSX, specifically GSX version 2, tailored for that OS and hardware.
Got it. The graphics engine.
Then comes the really clever part, the GM services layer. This provides all the high-level building blocks for a GIRE managing windows, handling mouse clicks, drawing icons, scaling things. It's the core abstraction magic.
And finally, the bit the user actually interacts with.
That's the GM desktop. It's technically just an application itself, the first one that loads, and it gives you that graphical file management, the icons, the trash can, all that stuff.
How did they make this whole stack portable, though? That seems like the hard part.
Mostly by writing it in C. The vast bulk of the code, the complex stuff in GM services, the desktop application logic, was written in the C programming language.
Ah, okay. C was known for being relatively portable even back then.
Exactly. So to move GM to a completely different computer, you'd mainly just need to rewrite small, specific bits of code, the low-level hardware drivers for the screen and the mouse. The core C code could largely stay the same.
That's pretty smart. It gives them flexibility. Where did they initially offer it?
Primarily on the systems most people had. Machines running on Intel 8086 or 8088 processors under either MS-DOS or concurrent CPM. You know, the IBM PC and its clones.
Makes sense to target the biggest market first.
But they were definitely thinking bigger. The review mentions they expected to port it pretty quickly to more powerful processors like the Motorola 68000.
The chip that was in the Mac.
Right. And also things like the National Semiconductor 32016. And they even saw Unix as an obvious candidate to run GM on top of.
Oh, wow, hold on. That's a big deal for 1985. They're launching mainly on pokey old DOS machines, but the underlying design is already anticipating running on much faster, totally different architectures like the 68000, maybe even Unix systems.
Yeah. They were engineering for the future, for a world beyond the IBM PC standard. They were betting that powerful hardware would come from various places, and they wanted GEM to be the common thread, the standard graphical layer on top.
That's the essence of the open system approach, isn't it? Apple controls everything, hardware, OS, GUI for perfect integration. DR is saying, we don't care what hardware you run, we'll provide the consistent software layer on top.
Exactly. It's a fundamentally different philosophy. And the GEM services layer was the key to making that work for developers.
Right. You said that handles the high-level GUI functions. How did that help programmers.
It basically hid all the complexity. If you were writing an application for GEM, you didn't need to worry about how to draw a window or how to track the mouse pointer on different graphics cards. You just made a simple call to a GEM services routine.
Like telling the system, hey, draw a standard window here.
Precisely.
Yeah.
And GEM services would handle all the underlying specifics for whatever machine the program was running on. The source actually makes a direct comparison. It says GEM services functions in much the same way as the ROM routines in Apple's Mac for application programmers.
Okay, so just like a Mac developer could use built-in tools in the Mac's hardware ROM to easily create UI elements.
GEM services provided that same level of convenience, but in software, running on all sorts of different PCs. It made developing graphical applications for the PC world suddenly seem feasible, maybe even easy, for the first time.
Okay, so we've got the why, the need for portability, and the how, this clever, layered, C-based architecture with GSX and GM services. But the real buzz, and maybe the controversy, was about what it actually looked like, right? The GBM desktop?
Oh, absolutely. That's where the déjà vu came in.
Yeah.
Because the desktop, which is technically just that first application that runs, the file manager, well, it looked an awful lot like something else.
Something from Cupertino.
You could say that. If you'd seen a Mac or even an Apple Lisa before, the resemblance was striking. Let's put it that way.
So describe it. What did you see when you booted up GEM?
Well, first off, the screen was this shaded gray color, meant to look like a desktop surface. Pretty standard now, but novel in.
Okay.
And right along the very top edge of the screen, you had the menu bar, file, edit, view, those kinds of things.
Just like Mac.
And icons. Icons down the left side, typically. Representing your disk drives floppy disks. Maybe a hard disk if you were lucky back then.
And, dare I ask?
Oh, yes. And the ubiquitous trash can for deleting files, sitting right there, looking very familiar indeed. They didn't even try to call it something else, like a wastebasket.
Wow. Okay. So blatant borrowing, maybe. What happened when you opened a disk icon?
You got a window showing the contents of the disk. And inside that window, more icons representing the files.
What kind of icons?
They had distinct ones. A little square shape for an application program, a piece of paper with a folded corner for a document file, and quite cleverly, a little manila folder icon to represent a DOS subdirectory.
Ah, okay. So they were mapping the graphical idea of a folder onto the underlying DOS structure. That makes sense.
Yeah, it's a good way to visualize it. And managing those windows felt pretty slick for the time.
How so?
You could resize them, shrink them down, expand them to fill the screen, drag them around anywhere on the desktop. There were standard symbols in the corners, like little diamond shape, to restore a window to its previous size.
So basic window management we take for granted now.
Exactly. But revolutionary if you were coming from just typing dir at a DOS prompt. You could even overlap windows or tile them side by side. It really opened up the possibility of looking at multiple things at once.
Okay, so the look was very Mac-like. What about actually using it for basic file stuff, like copying or deleting? Was it intuitive?
This is where GM apparently really shone. The reviewer raves about how logical and easy the basic file operations were. Drag and drop was king.
So how did you copy a file?
Simple. You just clicked on the file's icon, held the mouse button down, dragged it over to the icon representing the destination disk or folder, and let go. Done.
Nice. And deleting.
Even easier. Drag the file icon over to that trash can icon, drop it in, finished. The whole process was described as quick and simple.
That sounds genuinely user-friendly, a world away from typing copy A, mi5file.txtb.
Backup.
Absolutely. And you could even select multiple files at once. You draw a box around a group of icons with the mouse.
A selection rectangle or marquee?
Right. And then you could drag that whole group together, either to copy them or to dump them all in the trash can at once. That drag-and-drop simplicity was really the killer feature for making PCs seem less intimidating.
It wasn't all perfect, was it? The reviewer had some gripes, especially comparing it directly to the Mac's way of doing things.
No, not perfect. There were definitely some usability issues that showed maybe DR hadn't fully absorbed the why behind some of Apple's design choices. The menus were a big one.
What was wrong with the menus? They were at the top, like the Mac.
They were, but they behaved differently. On GM, the menus would drop down and just stay there as soon as your mouse pointer moved over the menu title, like File, Edit, whatever.
Okay, so what's the problem with that? Well, the reviewer found it increasingly annoying. Imagine you're working, maybe typing or editing something, and you accidentally move your mouse pointer just a fraction too high.
Ah, I see. The menu instantly drops down, covering part of your work, even if you didn't intend to open it.
Exactly. It could happen constantly, interrupting your flow. On the Mac, you had to actually press and hold the mouse button down on the menu title to make the menu appear and stay open.
Which requires a deliberate action from the user.
Right. The reviewer thought the Mac's approach was a much better idea because it prevented those accidental menu activations. It felt more controlled.
Okay, that makes sense. Annoying, but maybe not a deal breaker. Was there anything else?
Oh, yes. There was the legendary file renaming incident.
Legendary. Do tell. This sounds like a good story.
It's pretty funny and quite revealing. The reviewer mentions that he, along with 2 engineers from Digital Research.
Wait, the people who made the software?
Yep. The 3 of them spent 20 minutes. 20 solid minutes. Trying to figure out how to simply rename a file.
No way. Renaming a file. That's like file management 101.
You'd think so. They just couldn't find the option anywhere obvious. And eventually, they had to give up and do the unthinkable.
Don't tell me.
They had to resort to reading the manual. Apparently, it was the only time during the whole review they needed the manual.
That's incredible. So, where was the rename function hidden?
This is the crazy part. It wasn't in the file menu where you'd expect it. It was tucked away inside the Show Info dialog box.
Show info. But that usually just shows you, like, the file size, creation date, stuff you can't change.
Normally, yes.
Yeah.
But in GM's version of Show Info, the file name itself was displayed in that box as editable text with a blinking cursor. That's where you renamed it.
That is profoundly unintuitive. No wonder they couldn't find it.
Right. The reviewer basically says, I have no idea why they put it there. It's a perfect example of cloning the look without fully grasping the underlying user experience principles that make a GI feel natural.
Fascinating. So, great potential, looked the part, mostly worked well, but had some weird quirks. Let's talk about running it. Performance is always key. What kind of machine did you need?
Okay. System requirements. The review states the absolute minimum was 256K of RAM.
256 kilobytes. That sounds tiny now, but in 1985...
There was a decent chunk of memory. Not outrageous for a business PC, but definitely more than the base model IBM PC shipped with initially.
And how much did GM itself use?
Quite a bit. The core GM system software took up 128K, and then the GM desktop application, the visual part, needed another 70K on top of that.
Whoa, so 128 plus 70. That's 198K just for the environment. That leaves only about 58K free in a 256K machine. That's not much room left for actual applications, is it?
No, it wasn't. So DR came up with a slightly clunky but necessary workaround. When you launched an actual application, like a word processor or spreadsheet,
Yeah.
GM would essentially throw out the desktop application from memory, would unload that 70K component.
Ah, freeing up that RAM for the application you wanted to run.
Exactly. It meant you could run decent applications programs within that 256K minimum. The downside was a bit of a delay when you quit the application and wanted to go back to the desktop. It had to be reloaded.
Okay, a trade-off. What about boot time? Did it take ages to load all those layers? OS, GSX, GEM services, desktop?
On a system with only floppy disk drives, yeah, it was apparently pretty slow to start up. You had to load each chunk sequentially off a disk. A hard drive would have made a big difference.
But once it was loaded and running, how is the speed? This is where it gets interesting, right? Especially compared to the Mac.
This is the big surprise, the real engineering feat. Once GM was up and running, the reviewer found it to be very fast indeed.
Really? Even on typical PC hardware of the day?
Yes. He tested it primarily on a compact portable, which was basically an IBM PC clone using the standard and, frankly, quite slow Intel 8088 processor. Maybe running at 4.77 megahertz.
Okay, the 8088, not exactly a speed demon, especially for graphics. How did that compare to the Mac's brain?
The Mac was running the Motorola 68000,
Right.
which is just fundamentally more powerful chip. It had 32-bit internals, a 16-bit data bus. The 8088 was still chugging along with an 8-bit external bus. Big difference for moving graphics data around.
So the Mac had a significant hardware advantage for this kind of graphical work.
Huge advantage. And yet, the reviewer found GM's drawing speed on that slow 8088 compact to be comparable with Apple's Mac.
inoperable. That's amazing. How did they manage that? Pure software optimization.
It must have been. Really tightly written code in their graphics libraries. The GSX layer must have been incredibly efficient. They somehow squeezed performance out of that limited hardware that nobody thought was possible. It really leveled the playing field in terms of perceived speed.
But there had to be a catch, right? Was performance consistent across different types of displays? What about color?
Yes. Color, that was the caveat. The reviewer also tested GM on an ACT Apricot F1 machine, which had a color display.
Yeah.
And it was noticeably slower than the monochrome compact, particularly when updating the screen, redrawing windows, that sort of thing.
Why the slowdown with color?
More data to push around. The Apricot used what the review calls a 3-plane color display. Basically, for every single pixel on the screen, instead of just storing one bit of information, on, off, black, white.
You had to store multiple bits, one for red, one for green, one for blue intensity, maybe?
Exactly. 3 bits per pixel in this case. So every time the system needed to redraw a part of the screen, it was manipulating 3 times as much data in memory compared to the monochrome setup.
And the poor old processors just couldn't keep up as well.
Right. The conclusion was pretty stark and simple for the time. Color cost speed. If you wanted the responsiveness, you stuck with black and white. If you wanted color, you accepted a performance hit.
Makes sense. So fast on monochrome, slower on color. But there was another source of friction, wasn't there? The fact that the slick graphical interface was running on top of, well, DOS.
Yes. This was the Achilles heel in many ways. The Mac OS was built from the ground up for a graphical interface. GEM was layered over MS-DOS, an operating system that had absolutely no concept of windows or mice or icons. And that mismatch caused problems.
Like, give me an example.
Okay, remember the folder icons representing DOS subdirectories?
Yeah.
Graphically, dragging a file icon into a folder icon implies you're moving the file, right? Taking it out of where it was and putting it inside the folder.
Sure, that's the intuitive expectation.
But because of how DOS actually handled file paths and the copy command, what happened in GEM was duplication. If you dragged a file from the main disk window, the root directory, into a folder, the original file stayed in the root directory.
So you ended up with 2 copies, one in the root, one in the subdirectory folder.
Exactly. It consumed twice the disk space, which was precious back then, and it confused users. The reviewer actually mentions running out of disk space because of this unexpected duplication. It broke the graphical metaphor completely.
That's a pretty serious flaw, undermining the whole point. Any other DOS clashes?
An even worse one involved system files. Imagine you're a tidy user trying to organize your disk. You see all these weird system files cluttering up your main directory, command.com, maybe some drivers.
Yeah.
And you think, logically, I'll make a nice system folder and drag all those system files into it to keep things neat. Makes perfect sense in a GUI world.
Uh-oh. I sense disaster looming.
Total disaster. Because the next time you tried to boot the computer, DOS wouldn't be able to find its essential startup files. It expected them to be right there in the root directory.
So the machine wouldn't even boot properly.
Nope. And the only way to fix it, you had to somehow get back to a command prompt and manually edit your autoxxe.bat file, a text configuration file, to tell DOS where you'd hidden the system files.
Oh, come on. That's the exact opposite of user-friendly. You're forced back into editing obscure configuration files just because you tried to organize things graphically.
Precisely. It showed the fundamental mismatch between the graphical front end and the ancient command line OS underneath.
Yet, despite these flaws, the reviewers still seemed pretty positive overall, didn't they? How did GEM succeed in spite of these DOS issues?
Because, for the most part, for everyday tasks, the abstraction worked. The layers were effective enough that you could mostly forget that DOS is lurking somewhere underneath. The speed was good, the visuals were appealing, dragging and dropping felt natural for basic stuff.
It papered over the cracks well enough for daily use.
It seems so. And there's one area where GEM represented a monumental leap forward, completely redeeming digital research's unfriendly past.
What's that?
The error messages. Remember BDOS error on A?
Unforgettable, unfortunately.
Compare that to how GEM handled errors. The review describes the new dialog boxes as friendly, detailed, and graphical.
Graphical error messages, what did they look like?
There's an example screenshot mentioned. Instead of cryptic code, you get a clear picture like a hand held up in a S.P gesture.
Okay, visual cue.
And clear text telling you exactly what might be wrong and what to check, like, drive A is not ready, be sure the drive door is closed, that the disk is the right kind and is inserted correctly.
Now that is useful. It tells a normal person what to physically do to try and fix the problem. No more guessing about BDOS.
It's night and day, isn't it? That transformation from cryptic failure code to helpful graphical guidance was maybe GEM's biggest win for the average user. It showed DR really was trying to be user-friendly now.
Okay, so technically impressive speed, a visually appealing, if derivative, interface, some DOS quirks, but genuinely helpful error handling. How did the market react? Did computer makers buy into it?
Well, massively. The technical success, especially that speed on cheap hardware,
Yeah.
combined with the visuals, it generated huge momentum very quickly. In early 1985, GMM looked like it was going to sweep the board.
Really? Who signed up?
Major players. ACT, who made the popular Apricot computers, adopted it across their range. Acorn, famous for the BBC Micro, put it on their new ADC 300 business machine. ICL, a big name in Europe, was using it for a new system. They were proving the portability promise worked manufacturers could license GM and get an instant, modern-looking OS feel.
So established companies were buying in. Any big game-changing deals?
The biggest one, the one that really seemed to cement GM's future, was Atari.
Atari, like Pong and joysticks Atari.
The very same, though they were trying hard to get into the serious computer market then. Atari announced they were licensing GM for their upcoming ultra-cheap high-spec business machine.
And that machine became...
The Atari ST,
Yeah.
which is a hugely important computer. It used that powerful Motorola 68,000 processor, same as a Mac, but Atari was aiming for a much, much lower price point.
So GM running on the Atari ST meant you could get Mac-like performance and a Mac-like interface, but potentially for hundreds, maybe thousands of dollars less.
That was the idea. And by landing the Atari ST deal, DR positioned GEM as the graphical environment for a high-performance, affordable mass-market machine. This was huge, especially when you look at the competition.
What about Microsoft? Where was Windows in all this in early '85?
That's the key. Microsoft Windows was famously still in the pipeline. It had been announced, demoed maybe, but it was delayed. It was essentially vaporware at this point.
So GM was actually shipping or about to ship, while Windows was still just a promise.
Exactly. And other competitors. Vision, an earlier GUI attempt, was basically dead in the water, hasn't done anything, according to the review. IBM had its own thing called TopView, but it wasn't even out in the UK yet.
So DR had this wide open window of opportunity. They had the product, they had the performance, they had major manufacturers signed up, including Atari.
And they weren't just shipping the desktop environment. They were bundling applications too, making it a complete package out of the box.
What kind of apps?
The final bundle was supposed to include GEM Draw, which was described as a painting program, but with object-oriented features too, a real competitor to McPaint. Also, GEM Word Chart for business graphics, and even an icon editor so users could customize things.
It sounds like they had all the pieces in place to become the graphical standard for pretty much everyone except Apple.
It really looked that way in February 1985. GM seemed unstoppable.
Okay, let's wrap this up. We set out to see how GM tried to solve portability and user-friendliness, and how it's stacked up against the Mac. What's the final verdict from the 1985 review?
The reviewer is incredibly positive in the end. He concludes that GM absolutely succeeded in both of its main goals.
Both user-friendliness and providing that hardware-independent platform for programmers.
Yes. He was clearly impressed by how well it hid the ugly realities of DOS and PC hardware underneath. For the average user, the verdict was simple and powerful. GM was the best thing this side of a Mac. High praise indeed.
And for developers.
For them, it offered liberation. An open system, he calls it, a way to write advanced graphical software that could run anywhere without being locked into Apple's expensive box, and crucially, without being dependent on the whim of Big Blue, meaning IBM, and the control over the PC standard.
So GM was positioned as this great alternative, freeing the industry from both Apple's and IBM's dominance.
That was certainly the hope, and how it was perceived at the time. It felt like a democratizing force.
When you look at the bigger picture then, this GM versus Mac situation highlights that fundamental choice in computing, doesn't it?
Absolutely. The Mac was, in many ways, perfect because it was a closed system. Hardware and software designed together, totally optimized for ease of use and performance. The reviewer even admits the Mac would always win on that basis. But GM, even with its flaws, its DOS clashes, its slightly wonky renaming function, it represented the other path, the path that arguably ended up winning in the long run. The idea of a graphical environment that's abstracted from the hardware, something that can run on diverse machines, commodity hardware, whatever manufacturers could build cheaply and powerfully. GM proved it was technically possible to get great graphical performance on non-Apple, non-integrated systems.
So the fight wasn't just about who had the prettier icons, but about open versus closed standards and who would control the platform for the masses.
Exactly. It was about whether the future would belong to the perfectly curated walled garden or the slightly wilder but much more accessible open field.
And in early 1985, digital research looked like they were about to claim that open field. They had the momentum, the partners, the performance. Windows wasn't even properly out yet.
They had a genuine shot at defining the future of PC interfaces. But there's always a but, isn't there?
That overwhelming sense of déjà vu came back to bite them, didn't it?
It certainly did. When your product looks that much like Apple's revolutionary design, you can expect Apple's lawyers to take notice. And they did. The legal battle that followed forced DR to make significant changes to GM's appearance, crippling its initial Mac-like appeal.
Which kind of leaves us with a fascinating final thought, doesn't it?
Indeed. GEM proved the technical feasibility of a good, portable GUI on commodity hardware. Microsoft eventually capitalized on that same model with Windows. So the question for you to ponder is, what if digital research hadn't run into legal trouble? What if GM, in its original Mac-like form, had been allowed to flourish and become the dominant standard on Atari STs, on PCs, on all sorts of hardware before Windows 3.0 finally got good? How different might the computing landscape look today?
A great question to mull over. If you enjoyed this journey back to the GUI wars of the 80s, make sure you're following or subscribed because we'll be digging into more pivotal moments from tech history in future deep dives.
Until then, keep exploring.
Keep your curiosity sharp and may your pixels stay perfectly aligned.